Before I start my discussion, be sure that you have your notebooks with you, since you will be answering questions and taking down notes. Feel free to pause the video as you answer the questions. Let's start. Our topic for today is circuits. Specifically, we will be answering the following questions. How do voltage and resistance affect electric current? What are the safety precautions needed in using electricity? Let us have a review of your grade 7 concepts. Any source of arrangement of a source of energy like battery, connecting wires, and a load like bulbs is called circuit. A complete path in which electrical charges flow is called closed circuit. The charges that flow in an electrical circuit are the electrons. I hope you got 3 out of 3 in our recall from your grade 7 science. When you were in grade 7, we discussed that a circuit is similar to a water flowing through a pipe, wherein the pump is responsible for pushing the water through the pipe, and the water slows down as it passes through the turbine. The process continues until the pump stops pushing the water through the pipe. In a circuit, when the switch is closed, the dry cell or the voltage source will push the electrons or the charges through the wire into the light bulb. Then the electrons will flow again through the wire back to the dry cell, and the process continues. Here is the diagram showing the similarities between the flow of water in a pipe and the flow of electrons through a circuit. They have similar components like the pump and the dry cell, the pipe and the conducting wire, the turbine and the light bulb. The water is pushed by the water pump, while the electrons are pushed by the dry cell. The path of water is the pipe. The path of electrons is the wire. The component that slows down the water is the turbine. Light bulb slows down the electrons. Different components of a circuit can be represented using a symbol. Here are the electrical symbols we will be using. Cell. A cell is a source of electrical energy. This is the symbol for a cell. Battery. A battery contains numerous cells connected so that they produce more electrical energy, and the symbol for battery is this one. Observe that for a cell, it has only 2 horizontal lines with 1 vertical line longer than the other. The longer vertical line represents the positive terminal of the dry cell, and the shorter vertical line represents the negative terminal. Since you have 2 or more cells in a battery, so you have more vertical lines connected to the horizontal lines. Bulb. A bulb will light up only when it is in a circuit that is complete. These are some of the symbols for bulb. So you can use any of the two given symbols. A switch can be turned on or closed to let current flow or turned off, open to stop current flow. This is the symbol for a closed switch, wherein a closed switch allows electrons to flow. And this is an open switch that cuts off the flow of electrons. Motor. A motor turns current into motion. For example, in a hair dryer. So this is the symbol for a motor. Buzzer. A buzzer turns current into sound. This is the symbol for buzzer. A conducting or connecting wire is the path for charges. This is the symbol for the conducting or connecting wire. Ammeter. An ammeter measures the amount of current. The symbol is this one. A voltmeter measures voltage. This is the symbol for a voltmeter. Fuse. A fuse is an electrical safety device built around a conductive strip that is designed to melt and separate in the event of excessive current. This is the symbol for a fuse. A wall outlet provides alternating current from power plants. This is commonly used in our houses. This is the symbol for an AC voltage or wall outlet. Resistor. A resistor is an electrical safety device that converts current to heat. These are some of the symbols for resistor. How are we going to convert this circuit into a circuit diagram? You should know the symbol for each component. So this is the circuit diagram. This is the symbol for a dry cell. Take note that the positive terminal should be indicated in the circuit diagram. The wire is represented by a line. The light bulb is represented by this symbol. And since the light bulb is glowing, the circuit is closed. It is complete. So the switch that you will be using is the symbol for a closed switch. Let us summarize what we learned. What conditions are necessary to have a complete circuit? In order for a circuit to be complete, it should have the following components: voltage source, conducting path or wire, switch, load or resistor. Removing one of these components will not produce a complete circuit. In your houses, look for things where we can find circuits. How can you compare water pump pipe setup to a simple circuit? They have similar components like pump and dry cell, pipe and wire, turbine and light bulb. How is a closed circuit compared to an open circuit? A closed circuit allows electrons to flow, unlike an open circuit. To end my discussion, think about it. Like a circuit, we need different components in our lives to work properly. You may now proceed to your weekly home learning plan for the activities you will be doing related to circuits.